Hello, Honors Chem people. Welcome to Lab 7. It is the melting and freezing point of lauric acid, and here I am in the lab trying to make a video for you. Going to be a little less writing this time. We're going to see if we can do this and get the video to continue to scroll as well as hear audio. Big aspirations. Okay, here we go. So in this lab, you're going to be looking at freezing and melting points of something called lauric acid. Lauric acid is, yes, it's an acid, but it's an organic acid. It is not particularly corrosive or caustic. Here's a sample of it with a thermometer frozen right in there. Yeah, you can hold it with the thermometer, but don't do that because you're likely to drop the test tube. So when you come into lab, you're going to get your sample of lauric acid with the thermometer already frozen in there. You are going to start part 1 by preparing a hot water bath. We're looking for about 60 to 65 degrees Celsius. So it's not particularly important exactly that you hit 60 to 65 degrees. I'm just trying to give you a temperature range. And so that means when you are preparing your bath, you're going to want to monitor the temperature. That's what this is for. This is a vernier probeware assembly. So when it is all charged up, you will be able to be free from an AC cord. You will have a thermometer probe like this. You can actually see right now it's reading room temperature at about 26.8 degrees Celsius. If I hold the probe right in my hand, you should be able to see that the temperature is rising. It's that simple. It's alive. See, I'm up to 29.7, approaching 30 degrees Celsius as I hold the probe in my hand. So this is your first chance to use these. This is just to stir the water in the hot water bath and make sure that you're approaching the right temperature. It's a good time to get used to using probeware that we will be using in future labs. So set up that hot water bath using a hot plate, and once it is in that range, you want to kind of keep it there. You might have to remove the beaker from the hot plate. You might need to put it back on there, but you're going to constantly be needing to monitor. You want to keep it right around 60 degrees. Take the temperature of your frozen sample of lauric acid. So that's the temperature that you're going to get this at when it's given to you. Right now, if I read the temperature, room temperature right now, it's 22.0 degrees. So you have to see what it is when you get into lab. Put the sample into the water bath. You're going to stir with the thermometer and take temperature readings every 30 seconds. The key to this lab over and over again is stir. If you stir, you will get better results. So you're going to be stirring with the thermometer. There's not room for another stirring rod. So right now I can't stir using this thermometer, but once this starts to warm up, the sample is going to loosen up in the test tube and I'll be able to twist with my fingers, kind of back and forth, roll the thermometer in between my fingers, and every 30 seconds you're going to take a temperature reading and record it. You're going to do that until the temperature reaches 55 degrees Celsius of the lauric acid, not the water bath, of the lauric acid. At that point, you're going to get a second beaker, and you're going to prepare cool water. Probably right out of the tap will be good. 30 degrees is a little high. We might even go lower. Let's say 20 degrees Celsius would be good. If we need ice, we'll have that available for you. And once you have got that cool water bath ready to go, you're going to observe the temperature of the melted lauric acid. In part 2, you start with melted samples, and then you're going to immerse it into the cool water bath and take temperature readings every 30 seconds. You're going to stir. Key to this lab is stirring. I think I said that. I'll say it again. Stir until the thermometer freezes. For this part of the lab, if the thermometer is frozen back into place in your sample, just as the way it came to you, you cannot force it out. If you do force it out, you will break the thermometer. Okay? You're going to continue until the temperature reaches about 35 degrees Celsius. Do not start part 2 unless your sample is fully melted, and then you can put it in the cool water bath. The best part about this lab is if you mess up part 1 or part 2, we can always do it again because it doesn't take very long to collect this set of data. So you're going to construct a couple data tables, one for your heating, one for your cooling, one in each section, and then you're going to analyze your results by completing a graph. You may use Excel or you may use good old-fashioned graph paper, up to you. You're going to do that on your own time, and you're going to be comparing the melting and the freezing points. Okay? Questions follow after that. We'll see you in lab.